then you solve. So what would the two solutions be here to this problem?
X equals -3 and x equals -2.
Good. Any questions on that before we move on to another?
No.
All right. So I'll just make a note of this. 4 is just like number 1. So if we have time, we'll come back to that. But let's go look at like number 3 together.
All right.
All right. So x squared plus 8x minus 20. This is an a equals 1. The challenge of this one is you need to find two numbers that multiply to minus 20, but add to positive 8. What stands out to you? Like think about two numbers that are 8 apart.
Negative and positive.
And negative and positive, that's right. So like for a while, I've been making this long, almost grandiose list here. And it's like you don't need to do that, but you do want to have like some sense of where you're going. After -1 be -2 and 10, 2 and -10. Do you see anything here that works?
-2 and 10.
Yes. So we'd write x minus 2, x plus 10 equals 0. So what I'd like you to do is solve it from here. Set each of these factors equal to 0. Let me know what you come up with for your x values, please.
X equals 2, x equals -10.
Good. Got it. All right, so 2 is like this one. Same with actually 5 and 6. But let's, why don't you pick one between 5 and 6? Do you have a preference for which one we do next?
Let's go with 5.
Okay. So the letter C here, if you don't like it, you just change it to an X, but it's the same way. You're two numbers that multiply to -10, but this time they have to add to -3. It's still one positive and one negative. So, -1 and 10, that adds up to +9, 1 and -10. You notice most of the time you don't have to, it's more towards the middle. Do any of these work? Do any of these add to -3?
-5 and 2.
Yeah, so you'd write C plus 2, C minus 5. If you go the other order where you go C minus 5 first, that's okay. You set them both equal to 0 and solve here. So C is -2, C is +5. So let me know when you get that down, and I'm going to have you try 6 right now because we've got the list for -10, so it should go pretty fast because you've already got all the factors of -10. But will you try this one, please, and let me know if you have any questions.
All right. X equals 10, X equals -1.
Okay. So it sounds like you did X minus 10, X plus 1 equals 0, X minus 10 equals 0, X plus 1 equals 0, X equals 10, X equals -1. Good. All right. A few there for you to try on your own later on. Let's go to number 9 next. Here we go, number 9. All right, so this one is not A equals 1. It's related in some ways, but it's not A equals 1. It's got a 2 in front. Do you remember at all what we did with this 2? We pair it with something else. Do you remember what we paired it with?
Oh, the last number.
Yes. So take 2 times -9, which is -18. And you're looking for the factors of -18 now that add to -7. So could you let me know which ones work for that, please?
Sure. -9 and 2.
Okay. And so the choice here is to pair, which one is going to pair with the 2x squared? Is it going to be -9x or is it 2x?
2x.
Yes. Excuse me, I'm maybe going to sneeze here. Plus 2x minus 9x minus 9. And I wrote the word grouping here. You end up grouping the first two. What is the GCF between them? It's kind of
2x.
2x, good. And then you got to figure out what goes in parentheses here. What goes here? You're dividing each of these by 2x.
X plus 1.
X plus 1, fantastic. That goes here also. And then you figure out what goes in between them to get back to what you started with.
That's 9.
9 is 9x.
Oh,
And
-9.
yeah. And the difference might not seem like much, but it's like if it were a multiple choice test, both answers would be there and it would be very frustrating. So it's double factoring. You have an x plus 1 in both. Factor that out, and then 2x minus 9 equals 0. From here, you set that both factors equal to 0. X plus 1 equals 0. 2x minus 9 equals 0. Can you give me the two answers from here, please?
Sure. X equals 1 and x equals 9/2.
Okay, I agree with your second one, 9/2. The first one I disagree with.
Okay.
How do you undo what's here?
Oh, -1.
Yes. Yes, it's
Why
a
is
small thing.
the negatives that get me?
I think as a student, you think math is just another word for like details, and some ways it's true. It's the little things that seem to matter most here. All right, let's look at number 10. Number 10 here. You've probably noticed in all the problems we've done that it's always equaled 0. And this one doesn't equal 0, it equals 12. We want to move the 12 because then it will be just like the problems you've been doing. So you subtract 12 here, and that's 2m squared minus 5m minus 12 equals 0, like that. Okay, so you have to have it equal to 0. So like when you go back later on and you work a problem out like 7, you're going to set it equal to 0. You have to move that, whatever that number is, off to the other side. This one is a grouping problem though. It's that a not equal to 1. I call it a grouping. That 2 and the minus 12, what's the math operation there? What do you do to those two numbers? Just like the last problem.
Oh, you gotta multiply them.
Yes. 2 times minus 12 is minus 24. And now you're looking for two numbers that multiply to minus 24, but add to minus 5. Could you come up with those, please?
-8 and 3.
Okay, very good. Which do you pair with the 2m squared? You're going to pair minus 8m or 3m?
-8.
Minus 8m plus 3m minus 12 equals 0. From here, you're going to do the whole grouping thing. And I'd like you to kind of work it out from here and see if you got any questions.
All right. At 2m plus 3 and m minus 4.
So you said 2m plus 3, m minus 4, like that?
Yeah.
Okay, so you're not quite there, right? There's a little more to do. What's that next?
Yes, the next step. Equals 0. And then gotta find the things. M equals -3/2 and m equals 4.
Yes, very good. So 9 is, sorry, we did 9. 8 is going to be similar. 7, you're going to move that term over. 14 is similar. Oh no, I'm sorry, that's further up. Let me look ahead here. Try and decide why they're giving you so many. Sorry, I take that back. So the rest, 14 is the kind of the one that's maybe a little bit different. Let's do 14 together, and then we'll switch to the other stuff. Unless you tell me there's some like urgency to do one over the other.
Yeah,
Meaning like me.
There's no urgency.
Okay. All right, so let's look at 14 here. 2x squared plus 8x minus 64 equals 0. It's already equal to 0. That's good. You know, that's a check. We like that. You might look at it and say, oh, it's a not equal to 1. I have this 2, I multiply it minus 64. That does work, but it's not the best approach. You should always look for a GCF first. None of the other problems have had it. That's why I'm showing you this one, because it's got a GCF. It really helps when you do that. So 2x squared plus 4x minus 32 equals 0. And now this is an a equals 1. Okay, the 1, because of the part inside the parentheses, like you almost visually reset and you're like, all right, it's x squared plus 4x minus 32 equals 0. I don't even care about that 2. So can you find two numbers now that multiply to minus 32 but add to positive 4?
Sure. -4 and +8.
Yes. X minus 4, x plus 8. Very good. So you're going to set each of these equal to 0. What is your final answer here? What does x equal?
X equals 4. X equals -8.
Good. Okay. Great. So there's a few more problems there. Well, maybe half. I'd like us to move on to the sketching stuff, but that's my suggestion. What would you like to do?
We can go on to the sketching stuff.
Okay. So what I think I see here, and this is where I don't want to say this. How many examples do you have? Because I see example 2, example 3, but there might be an example 1 that I just didn't get the equation for. It just didn't, like, either wasn't sent or, you know, like the one. What do you see as kind of being next on your notes? Or
Um, I think that's just a typo.
okay, let me try to, sorry, let me maybe try to be clear here. I see, let me snip this in. I see this as example 2 with a bunch of things that follow, meaning like complete a table, what type of concavity. Is this the first example you have, or is there one before this?
There was one before it, but I did it in class.
Oh, good. Do we need to go over it? Any questions on that?
No.
Okay. All right. All right. All right. So here we go. It says first, what are A, B, and C equal to? that's referring to ax squared plus bx plus c. Sometimes you have to sort of add those here, 0x plus 0 to see them. Can you tell me the values of a, b, and c in this equation? What's the number in front of x squared?
Negative 1/2.
Good. What is the number in front of x?
0.
0. How about the number to the right of x?
Also 0.
So it's very helpful to write these in. I think what happens sometimes as a student, if you don't see anything, you tend to think it's the thing that's there, but 0 times x is 0, plus 0 is 0. This doesn't contribute to the equation, but it's the full form, okay? The vertex now, minus b over 2a. It's a little awkward, but you can write minus 0 over 2 times minus 1/2. There really is no such thing as minus 0, so you can treat it as positive 0 if you want. You don't have to like think it's negative or something all of a sudden. What else can I say here? Do you remember what 0 divided by any number is?
0.
It is 0. So the vertex is at 0. This is 0 over -1, which is still 0. Lots of zeros. So that's the x coordinate. Do you remember how to find the y coordinate of the vertex? I know it doesn't ask for that right here, but do you remember how to do that?
Not clearly.
So you put the x value of the vertex, in this case 0, back into the equation. So in this problem, it would be y equals minus 1/2 times 0 squared.
So it'd be 0.
Yes. Okay. And the reason you need that is for the table. You put the table, you put in the table the vertex right in the middle. Okay, so always put the vertex right there in the middle. Any questions on that before we keep going here?
No.
All right. So normally we have these 5 values, -2, -1, 0, 1, and 2. Okay. And we evaluate them in this equation. All right. So can you evaluate this for 2?
Sure. Yeah, -2.
Yes. Now I'm going to evaluate it at 1, -1/2 times 1 squared. So 1 squared is 1, -1/2 times 1 is -1/2. Does that, like, do you consider that to be a good point, the -1/2?
Good enough.
Okay. I like I answered that. So if I were in the classroom, I would say let's make sure these are all integers, not fractions. If your teacher said this is fine, if you're okay with it, then you can go with it. Do you remember how we get the other 2 points here?
I think it's one of the rules that was like kind of the same.
There's symmetry.
Okay.
So they're exactly the same. It's really important that you calculate them correctly because they are the same. Any questions on that?
No.
We're going to skip 2 for a moment. 2 is really better done from the graph. 3 we really should have done from the vertex. So the progression here would be vertex leads to the axis of symmetry. It's always the x coordinate of the vertex. And it's always an equation. So it's x equals a number, in this case, 0. That would be a good note card to have, or something to write down on a note sheet or something.
Yeah, I got it written down.
Okay. Number 4. 4 kind of comes, I mean, we have the vertex. That was I've had you find the x and the y value. The min or a max is based on whether it opens up or down, which comes from the value of a. A is the leading coefficient. If a is greater than 0, it opens up. If a is less than 0, it opens down. If it opens up, it has a min. If it opens down, it has a max. So there's kind of this like progression. It's like, does it open up? It does, because a is greater than 0. So it looks like this, which means it has a min. There's a lot of like transitive property, like this leads to this, leads to this, so on. So what do you say here? Does this one have a min or a max? What's the a value?
A minimum.
This one, a is -1/2. So another thing you could do is you could wait to answer this until you actually have the graph, because that will also tell you how to do it. So let's go ahead and graph this, then maybe come back and answer these questions. So you do this from the table. So your vertex was at 0, 0. If you make each of these 1, that's fine. Your graphs can be really compressed into this space. Did you guys talk at all about like maybe making 1, like going out two grid points to make 1?
Yeah.
Okay, that might be worth doing here. You would want to do the same thing on the y-axis, though. You don't really want to have different scales on each axis. Okay, so we've got a point 1, -1/2. Oops, that's there. I already messed that up. And then 2 was -2. Is that what we said? I think it was -2. Let me check here. Yeah, got that there. And then similarly over here, we got -1, -2. And then there's symmetry, so you can just you could sort of like come across to get the other points. Nice U shape. Nice U shape. Like that. Okay. Now we can answer some of these questions. Like, we don't have to guess, we don't have to use the rules. So some of it you can wait until you got the graph there. So let me know when you get that graphed.
Got it.
Okay. Is the point, excuse me, is this a max or a min? This top of the graph here.
Max.
It's a max. Okay. And then we did not answer question 2. Let me go snip it in. 2 is concave up versus concave down. Let me snip that, and then we'll talk about what that means. So the often the reference to concave up is that it would hold water, meaning it would not leak out. Something like that. Concave down does not. Is that how you maybe saw that in class?
Yeah.
Sometimes you hold like kind of hold your hand like cupped up, cupped down.
Yeah.
So it really falls in line with whether it opens up or down in this problem.
Concave up. Oh, wait, no.
Yeah, these are not intuitives. This is concave down. Trying to think of something that might be related to this. Drawing a blank. Okay. We can move on to example 3 now. Oh, I'm sorry. There's actually one more piece to find the zeros. Okay, so I'm actually going to move this, put this here, find the zeros. Okay, so the zeros are the x-intercepts where either it crosses or touches the x-axis.
So would that just be the vertex then?
Yes, it only has one. Like when we were factoring, those were zeros earlier. So sometimes it has 2. This one has 2. It's just called a repeated root because it touches. Root and 0 are the same thing.
Hmm.
We'll do another example. Maybe seeing another one will really solidify these things we've been talking about. There's a lot of steps. A lot of steps here.
Yeah.
Okay, quadratic equation, y equals 2x squared plus 4x minus 3. Can you give me the values of a, b, and c, please?
Sure. A is 2x squared.
So let's go back and look at the previous problem. Does a include the variable?
Yeah. Okay, it's just 2.
It's just a number. Yeah. You're not the first person to say that. What do you think it is that makes you think it's everything?
I don't know.
Yeah, I'm really curious too because it's like they put these on standardized tests just because they know students will say 2x squared. So, what about b? What about b here?
4.
Good. And c?
-3.
Good. All right. I want you to calculate minus b over 2a for me, please.
Okay. -1.
So -4 over 2 times 2 is -1. Good. That's the x coordinate. To find the y coordinate, you're going to put x equals -1 back in the original. So it's going to be y equals 2 parentheses -1 squared plus 4 times -1 minus 3. So will you evaluate that for us, please?
Okay. -5.
It is -5. Good. All right. So the vertex is -1, -5. Okay. So let's do the axis of symmetry next. Do you remember what that is? How we find it? It comes from the vertex.
It's X, so it'd be
X
-1.
equals, yes, you got it. Right. Okay, where's the X? There it is. All right, now let's go back and do the table. 5 good points. 5 good points. So the vertex goes right in the middle. -1, -5. And you go right to 0 and 1, and then left 2. And because there's symmetry, you don't have to do them all. You just have to do 2 of them. I would recommend doing the nice ones like 0 and 1. So will you evaluate the equation at 0, please?
Sure. It'd be -3.
It is -3, which means that -2 is also -3 by symmetry. And they do the same thing for 1.
-5.
Yes. Okay. Now I would graph it from here because it'll answer the rest of the questions pretty quickly for you. So we're going to do that. So let me get these points here. So -1, -5, 0, -3, and then 1, 5, 1, 2, 3, 5. Okay. Should look something like this. And now we can answer some of the other questions here. We can answer questions about concavity. Basically, you have to decide if this thing will hold water or not.
It will hold water.
Yeah. Did your teacher use this reference or something else for concavity? All right, really quickly here, let's do the last one here. So if you have to do this by hand, or I'm sorry, if you'd have to use this by the graph, you're basically estimating. It's about -2.5 and it's about 0.5. So if you have to do it exactly, this is where it gets a little dicey. 2x squared plus 4x minus 3. If you take the 2 times the -3 and get -6, this one does not factor, which means you end up having to use the quadratic formula. So what I think you'll have to do here is ask your teacher if, hey, do I need to use a quadratic formula for this? Or, can we just estimate them? That's where I'm really not sure. All right, so we're going to go ahead and stop the lesson here for today. Hopefully you're